Right, so we're back to the slide, and we discussed Charles's law and the deviation from Charles's law at very low temperatures. The volume of the gas will not decrease as expected, so that is your deviation, because of the forces of repulsion between the particles, as well as the volume of the particles. So when the particles starts clinging together, there will be stronger forces of repulsion. Sorry, I'm confusing you, I think. So when the kinetic energy of the particles decrease with the decrease in temperature, the particles moves less vigorously. So the forces of attraction makes these particles cling closer together. But we still want to be at a gas. We don't want to be at a liquid yet, because we're discussing gases. So as the gas particles are pulled closer together, the forces of repulsion becomes stronger. In your syllabus, they only look at the effect of the forces of repulsion and the volume of the particles. I think I tried to illustrate it in the previous video. With this video, I want to look at GAY-LUSSAC. So we're going to look at the deviation from GAY-LUSSAC's law. And GAY-LUSSAC's law says that the pressure of an enclosed gas will be directly proportional to the temperature, and here the conditions are that the moles as well as the volume is kept constant. Now, we know that this is the graph for the ideal gas. And we know three things about the ideal gas: their volume, particles volume is 0, forces of attraction repulsion 0, and collisions are elastic. But for a real gas, at very low temperatures, what happens? The kinetic energy decreases. If the kinetic energy decreases, there will be less collisions. Between the particles as well as the particles and the container that this gas is in. If there will be less collisions, there is a lower pressure. So the pressure decreases faster than expected. And that is the deviation. So for a real gas, at low temperatures, the pressure goes down faster than expected. Right. I'm going to switch to the textbook again in the next slide so that I can show you what happens there.